In today's lesson, we're going to learn about intersection and union, and we're going to solve compound inequalities involving and or. We'll start with the definition of intersection. The intersection of two sets A and B is the set of all elements in both set A and set B. The intersection of two sets A and B is denoted using this symbol here. This symbol that looks like an upside down U means intersection. In addition to using this symbol to mean intersection, the word and also implies intersection in mathematics. Let's look at an example. We're given two sets, set A and set B, and we're asked to find the intersection of A and B. Again, we see this upside down U, so we know that we're looking for the intersection. I'm going to start by drawing a Venn diagram. In this circle here, I'm going to put the elements in set A. In this circle here, I'll put the elements in set B, and in the middle, I'll put the elements that are common to both sets. Let's see. To start, set A contains the numbers 1, 2, 3. Now 4 and 5 are in set A, but they're also in set B, so I'm going to put 4 and 5 in the middle. For set B, the numbers 4 and 5 were also in set A, so we put them right here. And set B also contains the numbers 6, 7, and 8. The intersection of sets A and B is the set of elements in both set A and set B. So the intersection of two sets refers to what those two sets have in common. In this case, the intersection of A and B would be the numbers 4 and 5. Notice the intersection is defined as being a set. Therefore, if we're asked for the intersection, we want to use set notation for our final answer. That's why we used these curly brackets here, because curly brackets are used for sets that contain a finite number of elements. Next, let's define the union. The union of two sets A and B is the set of all elements in set A or set B or in both sets A and B. The union of two sets A and B is denoted using this symbol here. It looks like a U for union. So this symbol here means union, but there's also a word that means union in mathematics. In mathematics, the word or implies union. So in math, if you see this symbol or if you see the word or, you'll know that you're looking for the union. If you see this symbol or the word and, you'll know that you should be looking for the intersection. For this example, set A and set B are the exact same sets we saw in the example above. So I'm going to copy down this Venn diagram. Now we see this symbol here, so we know that we're looking for the union. And the union of sets A and B are the elements in set A or set B or both sets A and B. Another way to think about that is that if you're looking for the union of two sets, you just list all of the elements within those two sets. So again, we'll use the set notation, and then for the union, we just list all of the numbers in both sets. 1, 2, 3, 4, 5, 6, 7, and 8. So again, if you're asked to find the union of two sets, you just list all of the elements in both sets. If you're asked to find the intersection of two sets, then you only list the elements they have in common. Now, for these examples, sets A and B were finite sets because they just had a limited number of elements in each set. Next, we're going to look at infinite sets. These sets will contain infinitely many numbers within each set. And we're going to use the number line to help us visualize these sets. We'll start by graphing set A on the number line. We would read this notation by saying that set A is the set of all x such that x is greater than or equal to 4. For an introduction to set builder and interval notation, please watch my chapter 1.4 video. But as a real quick review, with interval notation, remember if you see a less than or equal to symbol or a greater than or equal to symbol, we use square brackets. And if you see a less than or a greater than symbol, we use parentheses. Square brackets mean that you're including the endpoints, and parentheses mean that you're not including the endpoints. So to graph this on the number line, we see a greater than or equal to symbol here, so we'll use a square bracket. Let's find 4 on the number line, and then we want to draw a set of x values such that x is greater than or equal to 4. So we'll draw our square bracket, and then to show values greater than or equal to 4, we'll draw our arrow going to the right. And I'm going to label this with an A since this refers to set A. Next, let's draw set B on the number line. Set B is the set of all x such that x is less than 1. So let's find 1 on the number line. And since we see a less than symbol, we use a parenthesis. And we want to represent x values less than 1. So we'll draw a parenthesis, and less than 1 means that we draw an arrow going to the left. Now, remember that this symbol means intersection. And if you're asked to find the intersection of two sets, that means you want to find what do the two sets have in common? Or in other words, where do these sets overlap? For this particular example, these sets have nothing in common. There is no overlap or intersection of these two sets. So for the solution here, I've written empty set. Next, we see this symbol here. So that means we're supposed to find the union of the two sets. Remember, if you're asked to find the union, you're just supposed to list all of the elements in set A, as well as all of the elements in set B, as well as any elements they have in common. So for the union, using interval notation, let's start by representing all of the elements in set B. Remember, with interval notation, we always start with the lowest number on the set. Well, set B goes off to negative infinity. So we'll start with negative infinity, and we always use a parenthesis next to positive or negative infinity with interval notation. And then we state the highest number in set B, which would be 1. And since there's a parenthesis at 1, we'll also put a parenthesis at 1 in our interval notation. So we've described all of the numbers in set B using interval notation. Then we're going to use this union symbol, and then we're going to describe all of the elements in set A using interval notation. So with interval notation, we start with the lowest number in your set, which is 4 in this case. And since there's a bracket at 4, we'll use a bracket in our interval notation. And then we put a comma, and then we list the highest number in the set, which would be positive infinity. So again, for the union, you just list all of the elements in both sets. Here we listed all of the elements in set B, and here we listed all of the elements in set A. Let's try another example. I'm going to start by drawing set E. Set E is the set of all x values such that x is less than or equal to 2. So let's find 2 on the number line, and I see a less than or equal to symbol, so we use square brackets. And we want x to be less than or equal to 2. So we'll draw our square brackets and our arrow showing all numbers less than or equal to 2. Next, let's draw set F on the number line. So we'll use a square bracket here, and we'll find negative 2, and we want to draw all x values greater than or equal to negative 2. So we'll draw our square bracket and our arrow going to the right, showing numbers greater than or equal to negative 2. We see this symbol here, so that means we need to find the intersection. The intersection of two sets is what those sets have in common. In other words, where they intersect or overlap, which is right here. So using interval notation, we can describe this intersection as being between negative 2, and we'll use a square bracket since we see a square bracket here, and positive 2, and we see a square bracket at positive 2, so we'll also put a square bracket at positive 2. Next, we see this symbol here, which means we're supposed to find the union of sets E and F. Remember, for the union, you just describe all of the numbers in set E as well as all of the numbers in set F. Notice in the previous example, there was a big gap between our sets. If there's a gap between your sets when you're describing the union, you're going to describe this set, and then you'll put a union symbol, and then you'll describe this set. Notice here there's no gap. In fact, the entire number line is covered. If we're tracing all of the numbers in set E, as well as all of the numbers in set F, we never have to pick up our pen. The whole number line is covered. So if your whole number line is covered with no gaps, we describe the union as being from negative infinity to positive infinity. Next, we're going to solve inequalities involving the words and or. We're going to start by defining a compound inequality. A compound inequality is formed by joining two inequalities with the word and or the word or. Here's one example of a compound inequality. It's simply two inequalities that are joined by the word And here's another example of a compound inequality. This is just two inequalities joined by the word or. We're going to start by looking at compound inequalities involving the word and. On the first page, we learned that in mathematics, the word and implies intersection. So if you see a compound inequality, like you see here, joined by the word and, we know that we're looking for the intersection. So I've just written the word intersection here under and. Now to solve a compound inequality, we start by just solving each inequality separately. So I'll start by solving this inequality on the left. We want to isolate x. So I'm going to start by adding 6 to both sides. That will leave us with negative 2x is greater than or equal to negative 8. And then let's divide both sides by negative 2. Now, be very careful when you're solving inequalities. If at any point you multiply or divide both sides by a negative number, you have to flip the inequality. So these negative 2's cancel, leaving us with x. We'll flip this inequality since we divided both sides by a negative number. And then negative 8 divided by negative 2 will give us a positive 4. Now, I'm going to go ahead and graph this on the number line. We're going to find 4, and we'll draw a square bracket. And then we want to represent all x values less than or equal to 4, so we'll draw our arrow going to the left. Next, I'm going to solve this inequality. If we distribute the 3, that will leave us with 3x minus 6 plus 7 is less than or equal to negative 2. We'll combine these like terms to give us 3x plus 1. Then let's subtract 1 from both sides. That will leave us with 3x is less than or equal to negative 3, and then we can divide both sides by 3. We're not dividing by a negative number here, so we do not need to flip the inequality, so we'll just be left with x is less than or equal to negative 1. Now, let's graph this on the number line. We'll find negative 1. We'll use a square bracket, and we want to represent x values less than or equal to negative 1, so we'll draw our arrow going to the left. Now remember, the word and means intersection. That means for our final answer, we want to know, what do these solutions have in common? Where do these solutions intersect or overlap? That would be in this region here. So to describe this intersection in interval notation, the region of intersection will go off to negative infinity. So we'll start by writing negative infinity. And then the highest point of our intersection would be right here at negative 1. And since we see a bracket here, we'll put a bracket here. So what does this answer even mean? It means that these are the solutions that both inequalities have in common. So you could pick any number in this region and plug it into both inequalities, and it would satisfy both inequalities. Let's try another problem. Again, here we see two inequalities joined by the word and we know that in math, the word and means intersection. Let's start by solving this inequality on the left. And if we solve this inequality, we're left with x is less than 3. Let's go ahead and graph this on the number line. We'll use a parenthesis at 3, and we'll draw our arrow going to the left since we want x values less than 3. Next, we'll solve this inequality. We'll start by distributing the negative 4 to get negative 4x minus 8 is less than or equal to negative 28, and then we can proceed to isolate x. Here, I'm dividing both sides by a negative number, so I'm going to make sure to flip the inequality, which leaves us with x is greater than or equal to 5. So I'm going to go ahead and graph that on the number line. We'll use a square bracket at 5. And since x is greater than or equal to 5, we'll draw our arrow going to the right. Now for the intersection, we're looking, what do these sets have in common? Where do they intersect? Or in other words, where do they overlap? These sets have nothing in common. There's no overlap, so for our solution here, I've written empty set. Next, we're going to learn how to solve inequalities that are written in compact notation. These two inequalities that you see here are examples of inequalities written in compact notation. An inequality written in compact notation can be solved by isolating the variable in the middle. So if we're trying to solve this compact inequality, we're going to zoom in on the middle, and we want to isolate the x in the middle. To isolate the x in the middle, let's start by subtracting 1. Now, with these compact inequalities, whatever you do to the middle, you have to do to the left side and the right side. So if we subtract 1 from the middle, we have to subtract 1 from the left and subtract 1 from the right. -2 minus 1 will give us -3. We'll have 3/4 x in the middle. And then 10 minus 1 will leave us with 9. Now we're still working on isolating x in the middle. To isolate x, one approach we could use to isolate x is to divide by 3/4. Another way we could isolate x is by multiplying by the reciprocal. I'm going to use that approach. So the reciprocal of 3/4 is 4/3. And if we multiply the middle by 4/3, we have to multiply the left and the right side by 4/3. If we simplify here, we could picture this as -3/1. So if we multiply the numerators, we take 4 times -3 to get -12. And if we multiply the denominators, 3 times 1 just gives us 3. Multiplying two reciprocals gives us 1. So we're left with 1x. And again, we could picture this as 9/1. So if we multiply the numerators, that would give us 36. And multiply the denominators, 3 times 1 would just give us 3. Then to simplify this, -12 divided by 3 gives us -4. And 36 divided by 3 gives us 12. So we've isolated x. What does this say? This says that x is between -4 and +12. Let's graph this on the number line to help us convert it to interval notation. I'm going to start by just putting a dot at -4 and a dot at 12. Now again, this says that x is between -4 and 12. So x is any number between these endpoints, -4 and 12. And then we just have to decide if we use parentheses or brackets. Next to the -4, we'll use a bracket. And next to 12, we use a parenthesis. To write this in interval notation, we'll start with the lowest endpoint, which is -4, and we'll use a bracket, put a comma, and then we'll list the highest endpoint, which is 12. Let's try one more example. Again, we see this compact notation. To solve an inequality like this written in compact notation, we need to isolate the variable in the middle. So we're going to work to isolate x in the middle here. To start, the opposite of dividing by 2 would be multiplying by 2. So let's go ahead and multiply this quantity by 2. And if we multiply the middle by 2, we have to multiply the left and the right side by 2. Let's see, 2 times -2 will give us -4. These 2's will cancel, leaving us with -3x minus 4 is less than or equal to 16. We still need to isolate x, so let's add 4. That will leave us with 0 is less than -3x is less than or equal to 16 plus 4 will give us 20. And the last step to isolate x in the middle will be to divide by -3. Now be very careful here with inequalities. If you divide by a negative number, you have to flip the inequality. So I'm going to flip this inequality and also this inequality. 0 divided by anything is 0. These -3's will cancel. And -20/3 cannot be reduced, so we'll leave it as -20/3. So this says that x is between 0 and -20/3. To graph this on the number line, let's find 0, and for now I'm just going to put a dot at 0. If you have a fraction that you want to graph on the number line, you might find it helpful to convert it to a decimal. If you punch -20 divided by 3 on your calculator, you'll get -6.6 repeating. So that would be right about here. We know that x is between those two endpoints, so we'll draw a line connecting those endpoints. And then we just need to decide if we need parentheses or brackets at each endpoint. Let's see, next to the 0, we should be using a parenthesis. And next to -20/3, we see this symbol here, so we should be using a bracket. For our final answer in interval notation, we start with the lowest endpoint, which is -20/3. Then we put a comma and list the highest endpoint, which is 0. What do these solutions even mean? Well, this means if you plug in any number in this region here in for x, you'll get a quantity that's between -2 and 10. If you plug any number in this region in for x here and compute this, you'll get a quantity that's between -2 and 8. On this last page, we're going to look at compound inequalities involving the word or. Remember, on the first page, we said that in mathematics, the word or implies union. So if you see two inequalities joined by the word or, you will know that you will be looking for the union. To start, we'll solve this inequality separately and this inequality separately. We'll start by distributing the 3 to leave us with 6x minus 9 minus 1 is less than or equal to 8, and then we'll proceed to solve this inequality. Now let's go ahead and graph this on the number line. Next, let's solve this inequality on the right. We'll start by distributing the -2 to leave us with -2x minus 8 plus 7 is less than -9, and then we'll proceed to solve this inequality for x. And since we divided by a negative number here, we'll make sure to flip the inequality, and that will leave us with x is greater than 4. And we went ahead and graphed this on the number line. Now for the union, you're supposed to describe everything in both sets. Everything in the blue set as well as everything in the pink set. We can describe everything in the blue set using interval notation as -infinity to 3. Then we'll draw our union symbol, and then everything in the pink set can be described as 4 to positive infinity. So what does this solution mean? This means that if you pick any number in either of these regions and plug them in for x, that x value will satisfy either this equation, or it might satisfy both. Let's solve one last problem. I see the word or, which means union. Let's start by solving this inequality on the left. We'll start by adding 2 to both sides. Now to isolate x, we can either divide by -2/3 or we can multiply by the reciprocal. I'm going to multiply by the reciprocal. If you flip this to find the reciprocal, you'll get -3/2. And then we have to multiply the other side by the reciprocal. Multiplying these two reciprocals gives us 1, so we're left with 1x. Remember, if you multiply or divide by a negative number, you have to flip the inequality. Since we multiplied by a negative number here, we have to flip that inequality. And then if we multiply this, we can picture this as -2/1. And then if we multiply the numerators, we'll get a +6. And if we multiply the denominators, we'll get 2. And this simplifies to x is less than or equal to 3. If we graph this on the number line, it will look like this. And then let's go ahead and solve this inequality. Let's start by multiplying by 3. These 3's will cancel, leaving us with 5x minus 3 is greater than or equal to 12, and then we'll proceed to solve for x. And we're left with x is greater than or equal to 3, so let's graph that on the number line. Now, for our final answer, we're supposed to find the union of these two sets. Notice when we found the union of these two sets, there was a gap in the number line. So to describe the union, we described this set here, then we put our union symbol, and then we described this set here. There is no gap in this number line. In fact, the entire number line is covered. So all of the solutions in blue, as well as all of the solutions in pink, can be described as negative to positive infinity. Now for this problem, we saw the word or, so we needed to find the union of these two sets. But as a side note, what if we had seen the word and here? In other words, what if we were supposed to find the intersection of these two sets? These two sets actually only intersect at one number. That number is 3. For our final answer, we only use interval notation if there are infinitely many numbers in our solution. If there's only one number in our solution, instead of using interval notation, we just draw these curly brackets and insert that one number inside those brackets. So the intersection of these two sets is only one number, which is 3.